Hey everyone! So today we're going to be discussing some really cool female computer scientists who have made some really significant contributions to the world of computer science. And there are hundreds more, but here are some that we picked out. So starting us off, we have Grace Hopper. A huge part of her career was her involvement in the U.S. Navy. She was an admiral and became the oldest serving officer in the U.S. Armed Forces. When the time came for her to retire, she was devastated because she enjoyed working there. One of her most famous achievements is her contribution to the Harvard Mark I, a general-purposes electromechanical computer used in the war effort for World War II, which was the beginning of her computing career in 1944. She was one of the first programmers to work on it, and she created the 500-page-long manual of operations for the automatic sequence-controlled calculator for the computer, which detailed the foundational operating principles of computing machines. Hopper was also the inventor of the compiler, an intermediate program that translates English language instructions into the language of the target computer, an extremely useful invention because computers can't understand the source code directly. So a compiler is the intermediate between a human-readable format and machine-readable format. This was highly influential for many other computing developments, such as code optimization, subroutines, and formula translation. Program optimization, code optimization, or software optimization is the process of modifying a software system to make some aspect of it work more efficiently or use fewer resources. A subroutine is a sequence of program instructions that performs a specific task packaged as a unit. This unit can then be used in programs wherever that particular task should be performed. Fortran, or formula translation, is a general-purpose, compiled imperative programming language that is especially suited to numeric computation and scientific computing. So, regarding her early life and her education, Grace was born in 1906 in New York City to Walter Fletcher Murray and Mary Campbell Von Horn, who were of Scottish and Dutch descent, and attended West End College Church. She was the eldest of 3 children. In 1928, she graduated Phi Beta Kappa from Vassar College with degrees in mathematics and physics, and after received her master's degree in mathematics from Yale. Hopper began teaching mathematics at Vassar while pursuing her doctorate. She completed her PhD in mathematics from Yale in 1934. Her dissertation, New Types of Irreducibility Criteria, was published that same year. You may have noticed that her last name doesn't match her parents, and it's because she married New York University professor Vincent Foster Hopper from 1930 until their divorce in 1945. She didn't marry again, but chose to retain his surname. On New Year's Day of 1992, Hopper died in her sleep of natural causes at her home in Arlington, Virginia. She was 85 years of age. She was interred with full military honors in Arlington National Cemetery. So Hopper received many awards for her services to the computer science world, but also to the U.S. Navy. Many colleges have commemorative plaques or some reference to her, and she got 40 honorary degrees from universities worldwide. She also worked on a bunch of other projects and maintained a legacy that will continue on. Her legacy was an inspiring factor in the creation of the Grace Hopper Celebration of Women in Computing. Held yearly, this conference is designed to bring the research and career interests of women into computing to the forefront.
Up next is Margaret Hamilton. Margaret Hamilton led the software engineering division of the MIT Instrumental Laboratory. In fact, she was actually the person who coined the term software engineering. She also worked on software development for Apollo 11, which was the first spacecraft to complete a successful mission that placed humans on the moon in 1969. Furthermore, Hamilton's insistence on thorough testing is credited with the mission's success and the safety of its astronauts. Merely 3 minutes before the lunar lander reached the moon's surface, several computer alarms were triggered, and Hamilton's software captured these alarms and alerted these astronauts with the priority alarm displays. These alarms were triggered because the computer was overloaded with interrupts, and thus Hamilton's priority alarms warned the astronauts. This means that the software inside the computer was able to realize that it was being asked to perform more tasks than it should be, and then send out an alarm. The computer was also programmed with a complete set of recovery programs as well, and in this case, it eliminated lower priority tasks and re-established the more important ones. If the computer hadn't recognized this problem and taken recovery action, Apollo 11 would have likely not been the successful moon landing it was. She also helped develop guidance software for Apollo that was later adapted for use in Skylab, the space shuttle, as well as the first digital fly-by-wire systems in aircraft. Ultimately, she received the NASA Exceptional Space Act Award for technical and scientific contributions in 2003 and the Presidential Medal of Freedom Award in 2016 for her absolutely remarkable accomplishments. She was born August 17, 1936 in Paoli, Indiana. She studied mathematics at the University of Michigan in 1955 before transferring to Earlham College, where she earned a BA in mathematics with a minor in philosophy in 1958. At Earlham, she met her first husband, James Cox Hamilton, and they married each other in the summer after Margaret had graduated. She taught high school mathematics for a short time while her husband completed his undergraduate degree. Then, the couple moved to Boston in the summer of 1959, and Margaret Hamilton began working in the meteorology department at MIT. And from here, her career would grow until she joined the Charles Stark Draper Laboratory, which worked on the Apollo space mission. Keep in mind, this is only a brief intro into their lives. There is so much more interesting aspects to their lives and legacy that we have not fully covered, but hope that you'll find inspiration in their achievements.